Good morning. This is the last Math 93 Spring 2021 video that I'll be making. And just a couple of things. This weekend, I will not be available, most likely. So any questions you send me over the weekend, probably you won't get a response to until late Sunday night or Monday morning. Your final exam is Monday. It's to be completed by Monday night at 11:59 p.m. When I have your exams corrected and your grades calculated and all of that, I will email each one of you personally with your grade. So don't bother sending me emails ahead of time asking for your grade, because I won't be sending them out until I've got them all done. That should happen, I would say, no later than Wednesday. Anyway, let's go ahead and get started. So the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc and I will respond as soon as I can. Okay, so today we're going to be reviewing Chapter 10 and Chapter 11 for the final exam. And so let's go ahead and get started. Let's see here. Here we go. All right. So first thing we're going to look at is the square root property. Over here on the left in WebAssign, we have the following problem. Z squared minus 54 equals 0. So to use the square root property, recall we want to have a perfect square on one side of the equation that contains the variable and a constant or a number on the other side of the equation to start with. So the first thing I'm going to do is I'm going to add 54 to both sides of the equation, which gives me that. Then I'm going to take the square root of both sides of the equation. Recall that when I take the square root of both sides of the equation, I put a plus or minus on the side with the constant. So plus or minus the square root of 54. Now, if we can simplify this, we should, and we can, so we will. Let's see, the square root of 54. Well, 54 is 9 times 6. The reason I chose that is because 9 is a perfect square. The square root of 9 is 3 on the outside, so I get z equals plus or minus 3 square roots of 6. Now, entering that into WebAssign, I'm going to have, let's see, we'll go negative 3 square roots of 6. Then again, make sure I move outside of the radical to put the comma in there. Let me explain. If you put the comma right there, that just confuses WebAssign and they'll mark it wrong. So you've got to move outside, comma, space, and then 3 square roots of 6. Okay, and let's see what happens. Alrighty, let's take a look at this problem. It's another square root property problem. So we have the quantity x plus 9 squared equals 25. We already have a perfect square containing a variable on the left side of the equation and a constant on the right side. So it's time to take the square root of both sides of the equation. Again, don't forget the plus or minus. So we get x plus 9 equals plus or minus the square root of 25 is 5. To solve for x, we'll subtract 9 from both sides. So x equals negative 9 plus or minus 5. So let's see. Negative 9 plus 5 would be negative 4. Negative 9 minus 5 would be negative 14. So here I have, let's see, negative 4, comma, space, negative 14. And all right, I'm 2 for 2. All right, let's go down here and take a look at problem number 5. It says, use the quadratic formula to solve the equation. So we have x squared plus 16x minus 64, oh, excuse me, equals negative 64. So we're going to add 64 to both sides of the equation to put this second degree or quadratic equation in standard form. Descending powers of the variable, everything set equal to 0 on the other side of the equation. So now A is 1, B is 16, and C is 64. Recall that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Continuing to simplify, x equals negative 16, oops, plus or minus the square root of, let's see here, what is 16 squared? 256 minus 4 times 1 is 4 times 64 is 256, and all of that over 2. So x equals negative 16 plus or minus the square root of 0 over 2, 256 minus 256. X equals negative 16 plus or minus, well, the square root of 0 is 0, all over 2. Well, negative 16 plus 0 and negative 16 minus 0 is still just negative 16. So our only answer is x equals negative 8. So we're just going to put in negative 8. All right. Let's take a look at, let's do number 7. Okay. Use the quadratic formula to solve the equation. So I get 7x squared plus x minus 8 equals 0. This is already in standard form. So A is 7, B is 1, and C is negative 8. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals negative 1 plus or minus the square root of 1. Let's see. Negative 4 times 7 is negative 28 times negative 8 is going to be a plus. Let's see, what did I say? 4 times 7 is 28 times 8 is 224 all over 14. So x equals negative 1 plus or minus the square root of 225 over 14. Now, I think 225 is a square, so let's see, we're going to take the square root of 225, and we get 15. So x equals negative 1 plus or minus 15 over 14. So x equals negative 1 plus 15 over 14, which is 14 over 14, or 1. X equals negative 1 minus 15 over 14, which is negative 16 over 14, or negative 8/7. So x is what? 1 and negative 8/7. It doesn't say this on this particular problem, but be careful. Sometimes it says to put the answers from smallest to largest, in which case we put the negative 8/7 first. Let's see what we've got here. So we need to use the fraction. So we've got negative 8/7. Move the thing out, comma, space 1. All right. And let's see. Let's do, how about number 9? Yeah, let's take a look at number 9. should go ahead and write this here. I guess it doesn't really matter. Number 9. So x squared equals x plus 3. So I'm going to move everything over to the left side of the equation because I'd like to have my leading coefficient, that is a. I'd like to have it positive. So now a is 1, b is -1, and c is -3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals, well, negative times negative is positive, so 1 plus or minus the square root of 1 plus, because -4 times 1 is -4 times -3 would be +12 all over 2. So x equals 1 plus or minus the square root of 13 all over 2. Now, I can't simplify the radical. Hang on just a second. I'm going to pause things here. Okay, so as I was saying, we can't simplify the square root of 13. So x is going to equal 1 plus the square root of 13 over 2, comma, 1 minus the square root of 13 over 2. All right, so let's see how we're going to enter that in WebAssign. Okay, I'm going to need the fraction bar. And in the numerator, I'm going to have 1 plus, let's see here, the square root of 13 all over 2. Then again, I'm going to use the right arrow and move it outside, comma, space, another fraction bar, 1 minus the square root of 13 all over 2. Let's see, everything looks okay? Yeah, it does. All right. There's the answers. Okay, let's take a look at problem number 11. Here we have an equation with some fractions. So we've got x squared over 4 plus 9/4 x equals -1. So to make it easier to deal with, the first thing I'm going to do is clear the fractions. So I'm going to multiply both sides of the equation by the least common denominator of 4, 4, and 1. Okay, because there's an implied 1 here. So 4 times x squared over 4, if the 4's would reduce out, I'd have x squared. 4 times 9/4 x, the 4 would reduce out and I'd have 9x. And -1 times 4 is -4. So now I've cleared the fractions out. Next thing I'm going to do is get everything on the left side of the equation set equal to 0 on the right side of the equation. So now I'm ready to use the quadratic formula. A equals 1, b equals 9, c equals 4, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Every time I say AC, I think about air conditioning and how nice it would be. Okay, x equals -9 plus or minus the square root of 81 minus 16. Minus 4 times 1 times 4, all over 2. X equals -9 plus or minus the square root of, let's see here, I'm feeling lazy, so I'm going to use my calculator. 81 minus 16 is 65 all over 2. All right, now, 65 doesn't contain any perfect square factors. And since it's a square root, that's what I'd be looking for. So I can't simplify this any further. So let's take a look and see if we have any of the answers over here. I don't see. Wow. Oh, you know what? there's the correct answer is there, but what did I forget to do? I forgot to bring that negative sign up there. It's a good thing this was multiple choice. So this would have to be the correct answer or answers. Saved by the multiple choice. All right. Okay, let's take a look at this problem. It says, refer to the graph, fill in the blank. F of x equals 2x squared minus 12x plus 16 is called a quadratic function. Its graph is a cup-shaped figure called a or an parabola. How about this one? The lowest point in the graph is 2, -1. This is called the vertex of the parabola. The vertical line x equals 2 divides the parabola into 2 halves. This line is called the axis of symmetry. Now, in WebAssign, we don't graph the axis of symmetry. It's a dotted line. But if we were doing this freehand on graph paper in a classroom, you would graph it as a dotted line. And the other thing about this is to note that the axis of symmetry is a line. So the equation is x equals 2. It wouldn't just be 2, but it would be x equals 2. A lot of people miss that on tests and homework. But anyway, this line is called the axis of symmetry. All right. So now we have a problem that's in the form y equals a times x minus h squared plus k. Recall that the vertex is, we'll say the vertex is at h, k, and the axis of symmetry is at x equals h. So the vertex, and notice there's already parentheses. Some of you put parentheses inside the box and then it marked it wrong, and it's just got to pay attention to the details there. Okay, so our vertex is going to be at 1, 5. So 1, comma, space, 5. The axis of symmetry is going to be at x equals 1. Oh, does the parabola open upwards or downwards? Remember, if a is greater than 0, it opens upwards. A is less than 0, it opens downwards. Since in this case, a is 1, it would open upwards. All right, let's do another one of those. Let's see. Yeah, we'll do this one. So now the vertex here would be at what? -3, comma, space, -4. Okay, because x minus h would be x minus -3, and then plus k. Okay, axis of symmetry is at x equals -3. Here, a is negative, so the parabola opens downwards. All right, now we're going to do all that same stuff, but then we're going to graph it as well. Let's see here. So f of x equals x plus 3 squared minus 2. So the vertex is -3, comma, -2. The axis of symmetry is x equals -3. So let's put that in. Okay, the vertex is at -3, comma, space, -2. The axis of symmetry is at x equals -3. Now, let's review how you graph a parabola in WebAssign. You start out by clicking on the parabola button till it turns blue. We need to plot 2 points. The first point is the vertex, which is -3, -2. And then I need to plot a second point. So I'm going to need to calculate a second point. Okay? What I'm going to do is this. I've got -3, -2 as one of my points. I'm just going to go immediately to the right or the left. Let's go to -2, which would be to the right of the vertex. And let's find what f of -2 is. That would be -2 plus 3, the quantity squared, minus 2, which is 1 squared minus 2, which is 1 minus 2, which is -1. So -2, -1 is another point on the parabola. -2, -1 is there. Okay. So let's make sure that we plotted the points exactly where we want them. We did. Okay. And let's see what happens. All righty. Again, plot the vertex first and then another point. Make sure your points are plotted correctly by coming over here and looking at your ordered pairs. Do all of that before you push enter, since on a test you only get one shot. Okay. This is basically the same thing. Let's do this one because it talks about x and y intercepts. Find the x and y intercepts of the graph of the quadratic function. F of x equals x squared minus 4x minus 45. Recall, to find x intercepts, you set y equal to 0. Let's see, to find, and to find y intercepts, set x equal to 0. Oh, my writing is atrocious. Let's see here if we can clean this up a little bit. Have some pride in my work here. Okay. Okay, so to find x intercepts, we're going to set y equal to 0. We call that as y, so we get 0 equals x squared minus 4x minus 45. Well, to solve that, I'm going to use the quadratic formula. It's in standard form, set equal to 0. So a is 1, b is -4, and c is -45. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so x equals 4 plus or minus the square root of 16 plus, let's see, that 4 times negative times positive times negative is positive, and we've got what, 180 all over 2. So x is 4 plus or minus the square root of 196 over 2. X is 4 plus or minus. Let's see, is 196 a perfect square? That would be nice if it was. 196, 14. Miracles do happen. All right, so x equals 4 plus 14 over 2, which is 18 over 2, or 9. X equals 4 minus 14 over 2, which is -10 over 2, or -5. So our x intercepts would be at 9, 0, and -3. Wait, that's a 5. Can't read my own writing again. -5, 0. Okay. Now the y-intercept, we set x equal to 0. Well, f of 0 would be 0 squared minus 4 times 0 minus 45. So it's going to be -45. Now, I want to point out on these instructions, it says to put the larger x value first. So I'm going to write this one first. You can have the correct answers and you switch them around, and WebAssign marks them both wrong. So you've got to read and follow the directions. Okay. Also, a lot of people for intercepts, they left out the 0. They didn't write an ordered pair. It's got to be an ordered pair. 9, comma, space 0, and then 0, comma, space -45. Let's see here. That should be correct. And it is. All right. Let's go down to, now we have a different form of the quadratic equation. instead of the form y equals a times x minus h squared plus k, we have y equals ax squared plus bx plus c. When it's in this form, to find the vertex, first of all, we start off by finding the axis of symmetry. So the axis of symmetry is at x equals negative b over 2a. All right, and for this problem, f of x equals x squared plus 8x plus 16. Okay, and we've got, let's see, what have we got? A is 1, B is 8, C is 16. So x equals negative b over 2a, which is negative 8 over 2 or negative 4. So the axis of symmetry is at x equals negative 4. Now, they don't ask for that, but this is the x value of the vertex. So the vertex is at negative 4 comma f of negative 4, the corresponding y value. So we're going to put that in here. F of negative 4 is negative 4 the quantity squared plus 8 times negative 4 plus 16, which is 16 minus 32 plus 16, which is 0. So the vertex is at negative 4, 0. Okay. So negative 4 comma 0. Now, x-intercepts. To find x-intercepts, you'd set y equal to 0. So let's take a look at that. If we set that equal to 0, oh, that's the same thing we just had, isn't it? Yeah, and those are still true, but now we're going to use the quadratic formula. Okay, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 8 plus or minus the square root of 64 minus 64 over 2. X equals negative 8 plus or minus the square root of 0 over 2. X equals negative 8 plus or minus 0 over 2. X equals negative 8 over 2, which is negative 4. Oh, so the x-intercept is at negative 4, 0. Well, that's the same thing as the vertex, isn't it? I wonder why that's happening. Well, we'll figure that out eventually here. The y-intercept, you set x equal to 0, and the y-intercept is going to be at what? 0, 16. Okay. Well, to plot the graph, I need the vertex and one other point. Well, the x-intercept's the same point, but I could use the y-intercept. So turn it blue, negative 4. Oh, notice the scale here. Each little hash mark is 2 units. So negative 4, 0, 0, 16. Let's see. I said negative 2, but negative 4, 0, 0, 16. Okay. So that should be correct. So look at the graph. Notice this. The vertex lies on the x-axis. So no wonder there was only one x-intercept, and it was the same point as the vertex. Okay. Let's see here. That's the same stuff. Same stuff. I want to get down here to some story problems. And let's take a look at this one. A fireworks shell is shot straight up with an initial velocity. Hang on here. Let me make it so I can read all this. There we go. A fireworks shell is shot straight up with an initial velocity of 120 feet per second. Its height, s, after t seconds is given by the equation. S equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right, well, let's take a look at this quadratic equation that they've given us. First of all, I'm going to rearrange it and put it in standard form. So that would be a parabola, and since A is negative, it would be a parabola opening downward. So that represents the path of the fireworks. We want it to explode at the highest point, which would be up here at the vertex, okay? So let's see, time is the input, and distance or height above the ground is the output. So our vertex is going to give us the time at which it reached the maximum height and the maximum height. So we need to find the vertex, okay? So we're going to use x equals negative b over 2a. Technically it's t, but we're going to keep it in x for now. Let's see, what have we got? A is negative 16, b is 120. So this would be negative 120 over 2 times negative 16, which is negative 120 over negative 32. Negative divided by negative is positive. 120 divided by 32 is 3.75. So that's the time, 3.75 seconds, 3.75, and the units are already there. The height, so we would be finding what? Basically s, if it was written as a function, s of 3.75. Oh, I guess I should use this one. It doesn't really matter because the top one and the next, these are the same equation, but let's stick with that. So negative 16 times 3.75 squared plus 120 times 3.75. Calculator time. Negative 16 times 3.75 squared plus 120 times 3.75, and I'm getting 225. So that would be the height, 225. So the vertex of this parabola would be at 3.75 comma 225. So the time at which it reaches the highest point is 3.75 seconds, and that height is 225. Okay. Let's see here. I'm looking at the time, and I want to be able to spend some time on chapter 11. So I think I'm going to go on to chapter 11, and if we have time, we'll come back. But these are all problems very similar to what you had on your test. So you could go back there and check that if you wanted to. Look and see about your test. Okay, so we're going to get rid of that. And go back here. Take a look at chapter 11. Okay. Besides chapter 11, you just had a test over, right? Okay. Graph the function. Well, we can take time to graph it, but consider this. This is the form y equals b to the x, which means what? The domain is all real numbers. The range is greater than 0. The y-intercept is at 0, 1, and it's increasing. Okay, well, let's see. This one, and this one do not have a y-intercept at 1. This one has a y-intercept at 1, and it's increasing, so it's got to be that one, just by process of elimination. I know that was too quick and easy, wasn't it? All right, let's take a look at this one. Graph 5 to the x, same thing. It's going to be this one here for the same reason. Careful of the scale. All right, what about this one? Oh, the base is less than 1, so it's going to be decreasing. So it can't be this one or that one, but it's still going to have a y-intercept at 1. Well, the y-intercept here looks like it's up at 2, so it's got to be this one. Again, you could take the time to plot points, but if you just go back to the basic truths about exponential equations, you could figure it out. All right, same thing here, 1/2 to the f to the x. It's got to be decreasing. This one isn't going to work. Not only is the domain, well, the range is going below 0 because this has a shift on it. So it's got to be this one. Okay. All right, so much for graphing. Let's take a look here. Assume that there are no deposits or withdrawals. An account now contains $3,650 and has been accumulating interest at 6% annual interest compounded continuously. Aha, that's our first clue. So A equals PE to the RT, okay, because it's continuous. And what do we know? We know that, oh, we're going backwards. We don't know the beginning amount, but we know the ending amount is 3,650 because it says it now contains this. How much was in the account 5 years ago? So we don't know the initial amount. We know the ending amount. The interest rate is 6% annually, or 0.06, and the time is 5 years. All right. So we get $3,650 equals P times e to the 0.06 times 5. Because I'm going to end up isolating P before I'm done here, I am going to predetermine what 0.06 times 5 is, which is 0.3. Then I'm going to divide both sides by e to the 0.3 power. So P equals $3,650 over e to the 0.3 power. Calculator time, 3650 divided by e. Don't forget e is in this, the second function key of ln, natural log, to the 0.3 power. And I get 2703.986505. Since we're talking money, I'm going to round to the nearest cent. The 6 would round up, so we're going to have $2,703.99. So let's see. Oh, it does say to round to the nearest cent, doesn't it? Well, that's good. Okay. So $2,703.99. Okay. Let's take a look here at this one. Population of Earth is approximately 6.8 billion and is growing at an annual rate of 1.133%. Use the exponential growth model to predict the world population in 25 years. Okay, so let's see here. Right there, you can still see it. Okay, so we're going to use A equals PE to the RT. Now, when it's written as a number followed by words, 6.8 and then the word billion, and notice the answer is in billions, so we're not going to write 6,800,000, 000, 000, I think that's the number, right? We're just going to say P is 6.8 billion, okay? The growth rate is 1.133%, which is going to be 0.01133, okay? Careful converting the percent into a decimal number. And let's see, time is 25 years. Okay, so A equals 6.8 e to the 0.01133 times 25. Now, I could predetermine what's in the parentheses, but I'm just going to do it all at once, since I don't have to do anything later. So I'm going to go 6.8 and then second ln, so e to the 0.01133 times 25, close that up, equals 9.02657141. And this again is billions. Okay. Round your answer to 1 decimal place. So you'd round here. The 2 would round down. So it's going to be 9.0. Okay. Now, let's see what happens if I just put in 9. It should mark it wrong. Let's see what it does. It says it's correct. Well, just my luck. Technically, it should be 9.0 because we're supposed to round to 1 decimal place. But I guess I got away with it there. Okay. How long will it take $1,000 to double if it is invested at an annual rate of 6% compounded continuously? All right, we can do it the long way and use that formula. But since it's compounded continuously and it's going to double, the time is going to be the natural log of 2 divided by the annual rate. So let's save ourselves some time. The natural log of 2, close it up, divided by 0.06. And I'm getting 11.552455301. And it says to 1 decimal place, this 5 would round up, so 11.6 years.
I had a question on that problem.
This one,
Yeah, on the doubling. Does it matter? It doesn't matter on how much money it's talking about, correct? It just matters about the rate.
That's right. Because recall, if you do it the long way, P ends up being a number, A ends up being 2 times that, because you're doubling it.
Okay.
I can go further with that if you need.
No. It makes sense. It makes sense. I just because I remember we had a problem where it was like 4,000 goes up to 8,000, so it was just doubling. And yeah, I did the whole problem, the A equals PERT, and I got the same thing as if I were just to put the natural log.
And that 5 extra minutes you spent, you will never get back. Oh well.
Yes.
Okay. Yeah, you could do it that way. It just takes longer. All right, let's take a look at this one. Solve the equation. Let's see here. We've got 3 to the x plus 2 power equals 81. Because I can write 81 as 3 to the 4th power, I can now say that x plus 2 equals 4. The bases are equal, therefore the exponents are also equal. So we get x equals 2. Same thing with this. Let's see here. 6 to the 5x power equals 1 over 1296. 1296 is a power of 6. Let's see here. 1296 divided by 6. So 6 times 2, 16. And that divided by 6 is 36. So 6 times 6 times 6 times 6, 6 to the 4th power. So we've got that, which we can then write as that, taking the positive exponent, moving it upstairs to making it negative. We don't typically do that, but here's a case where we do. So 5x equals negative 4, x equals negative 4/5. Let's see what I need. I guess I'm not going to use the fancy stuff over on the right side. Guess I didn't need it. Okay, let's take a look at, let's see, what do we got left here? Write the statement log base 2 of 16 equals 4. So that would be what? 2 to the 4th power equals 16. So 2 to the 4th power equals, oops, I got to move outside there, equals 16. You okay with how I got that?
Yeah.
Okay. Write this statement in logarithmic form. This is going to be log base 2 of a half equals -1. So let's see here. I'm looking for the word log. Oh, here we go. No, here. So log base 2 of, and now I'm going to put in, let's see, I need a fraction. 1/2, and then outside of it equals -1. So log base 2 of 1/2 equals -1. Okay, let's see here. How about this one, number 16? Log base 2 of -4. Remember, you can't take the log of a negative number. So this is going to be undefined. And make sure you use capital letters just like it has it there. Okay. How about number 18? Let's do that one. Solve for x. We've got log base 5 of x equals 2. If I change this into an exponential equation, I get 5 squared equals x, which would be 25. Come on here, where are we here? 25. Let's see here. How about 21? Let's do 21. So we've got log base x of 1/100 equals -2. So changing it into exponential form, x to the -2 power equals 1/100. Well, I could write 1/100 as 1/10 squared, or as 10 to the -2 power. So if x to the -2 power equals 10 to the -2 power, x equals 10. Let's see here. How about 24? The natural log of e. Evaluate that without a calculator. Well, that's equal to some unknown I'm going to call box. But natural log is log base e. So I've got log base e of e equals box. Changing it to exponential form, e to the box equals e. Well, e has an implied exponent of a 1, so the box equals 1. So by the same token, what's this going to be? It's going to be 8. Okay. Let's see here. Looking for, here we go. Let's take a look at 38, and we're going to have to call it a day. Okay. All right. A wooden statue found in Egypt has a carbon-14 content that is 2/5 of that found in living wood. If the half-life of carbon-14 is 5,700 years, how old is the statue? All right, so we're going to use the half-life formula. A equals a sub 0 times 2 to the -t over h power. And we know that the half-life is 5,700 years, because it tells us that. It says that a wooden statue found in Egypt has a carbon-14 content that is 2/5 of that found in living wood. So a sub 0 is the starting amount. The ending amount is 2/5 of the starting amount. Or we could say, what, 0.4 of the starting amount? Okay, so we get 0.4 a sub 0 equals a sub 0 times 2 to the -t over 5,700 power. We're going to divide both sides by a sub 0. 0.4 equals 2 to the -t over 5,700 power. we're going to change this into a logarithmic equation. Log base 2 of 0.4 equals negative t over 5,700. And let's see here. I'm going to change the color to red. And so now I'm going to multiply both sides by negative 5,700. So then the 5,700s cancel out. Negative times negative is positive. T equals negative 5,700. Using the change of base formula, I get log of 0.4 over log of 2. I go to the calculator and I get negative 5,700 times the log of 0.4 divided by the log of 2. And I get 7,534.990141. And this is where a lot of people miss this. It says round your answer to the nearest 100 years, which would be 7,500 years. Okay, a lot of people miss that. Don't forget to read the instructions. When all else fails, read the directions. All right, time is up. You have any other questions? I'll be back at 1:15 this afternoon. Otherwise, have a great rest of the day. And I'm going to stop the recording.